Hi everyone, today we are going to talk about modeling athletic performance. And we are going to take a look at a model that we are going to use consistently throughout this course. So that model is what's called performance equals ability plus random chance. Okay, so before we move any further, let me define these three terms for you. So first off, performance is when the observed value that describes what an athlete actually did in a specific context. So the observed value that describes what an athlete actually did in a specific context. Okay, so an example is yesterday Matt Scherzer led in 4 runs. Carla's shooting percentage was 75% last season. So it's it's statistics that are published, okay? This is what actually happened. This is what they actually did. You could say if you were talking about yourself, maybe you hit 5 home runs during the regular season in your 2019 softball season at Canton High School. Okay, so it's what actually happened. Ability, however, is a little bit different. It's a true but unknown value. We would need an infinite number of trials under the same conditions to obtain a player's ability. Okay, so for example, maybe your track coach says, I know you have the ability to run a mile in under 7 minutes, okay? Well, they're using your previous performances. Maybe you ran a mile last month in 7 minutes and 10 seconds, and then maybe 7 minutes and 5 seconds, and then you got it down to 7 minutes and 4 seconds. So they're using your previous performances to estimate your ability when they say, I know you have the ability to run a mile in less than 7 minutes. Do they know that for sure? No, because it's an unknown value. They're just using those previous performances to motivate you to try and estimate what they think your ability is. Okay? And random chance is that variation between performance and ability. Okay, so let's say you average 10 points a game in basketball. Does that mean every single game you score exactly 10 points? Nope. There's variation in your performances, okay, and variation in those performances that are used to estimate your ability. So, I have normally if we were in class, we would do this together, and I'd have 5 volunteers, so I'm going to kind of just put down some data for you guys. I'd ask for 5 volunteers. You've been hired in at my coin flipping factory, okay? You've been through a thorough 2-week training on how to flip heads when you're flipping a coin. So your job is to flip heads when you flip a coin. So let's say my employees, I'll just call them employee number 1, 2, 3, 4, and 5. So let's say employee number 1, they each flip it now after they've gone through their thorough 2-week training. I ask them each to flip a coin 5 times. Okay, employee number 1 gets 1 head out of 5. Employee number 2 flips 3 out of 5. And then employee number 3 flips 2 out of 5. Employee number 4 flips 3 out of 5. And employee number 5 flips 4 heads out of 5. Okay? Now, let's say because of their poor performance, remember their job was to flip heads. So I'd like these percentages, these proportions to be as close to 1 or 100% as possible. So I'm going to fire employee number 1. I mean, their job was to flip heads, and they only flipped 1 out of 5 times they flipped heads. And I'm probably going to, maybe I'll fire employee number 3 too, because their job, they didn't do too well either. Now, on day 2, I ask them to do it again. Okay? So maybe employee number 2, they're pretty consistent. They flip 3 heads this time. And employee number 4, they go down to 2. And employee number 5, they flip 4 out of 5 again. Okay? I might now, because of their poor performance, fire employee number 4. And maybe I'll make employee number 5, they've done really well, employee of the month. Okay? I mean, remember, I told them their job was to flip heads, and this is what happened. So now let's take a look at this. Were the people who were fired really worse at flipping coins? So I fired employee number 1 and employee number 3. Were they really worse at flipping coins? No. The only difference between your good and your bad flippers was due to random chance. What do you think would happen if I let each employee flip the coin thousands of times? So I keep them here all day, and we keep a record of the number of heads they flip and the total number of flips they have. Well, what do you think would happen to that percentage of heads that's flipped? Well, it would get closer and closer to anyone's ability to flip heads on the coin, which is 50%. So they would get closer to their ability to flip heads, which is 50%. Okay, so hopefully that demonstrates that activity real quick, briefly demonstrates the difference between the terms performance, ability, and random chance. Okay, just a couple of vocab terms, you guys. When I use the term statistic is a value obtained from a sample. Okay, so this right here up here is a sample set of data. So if I said their ability, employee number 1's performance for flipping heads was 20%, that's a statistic that was from a sample. While a parameter is a value obtained from a population. Okay, so let's go to the back. On the back it says, we can use an athlete's performance to estimate their ability. Okay, so like I said earlier, we use the runner's performances for running the mile to estimate when the performances were right around 7 minutes to try and estimate what their ability is to run a mile. However, keep in mind this is only an estimate. We don't know if that runner can actually run the mile in 7 minutes. We're just using it to make an estimate. It may not be correct. Hopefully, though, it should be a close estimate if you have a large number of performances. So if they've run a mile over and over and over again, and you look at that sample of all that data, if you have a large enough sample, it should hopefully get you a good estimate of their ability. So another example is, suppose a basketball player's ability to make a free throw is 50%. That is, if she were able to take millions and millions of free throws without getting tired or learning anything new in the process, she will make 50% of them. Suppose that during a game she is fouled out and, she is fouled while attempting to shoot, and she is rewarded with 2 free throws. So, would you be surprised if this player steps to the line and misses both free throws? So, hopefully your answer is no. And we probably wouldn't be surprised because it's such a small number of attempts. It's only 2 attempts. Now, would this mean her ability as a free throw shooter decreased from 50% to 0%? No. Okay, remember, just because your ability is estimated to be 7 minutes to run a mile, it doesn't mean every time you run a mile in exactly 7 minutes. There's variation there due to random chance. So this demonstrates what every athlete has experienced at one time or another, which is performance is not the same as ability. Okay, so this is a template for our ability that we're going to use throughout this course. So if you have a highlighter, it'd be a good time to highlight it so you can remember where it is in your notes. But it says if, and then you would insert the team or the athlete you're talking about. So maybe the Detroit Tigers were to have millions and millions of whatever it is they're doing, so we could say at-bats, under the same conditions, they would get a hit about 26.7% of the time. Okay, so you just want to put it in context of whatever athlete or team that you're talking about and whatever activity is that they're doing. So let me give you an example. It says, what do we mean if we claim that Peyton Manning has an ability to complete about 65% of his passes? So if I'm using this template from above, it says if Manning were to an attempt, you can use millions and millions, or you can use infinite, whatever you prefer. So if Manning were to attempt an infinite number of passes, under the same conditions, so under the same conditions kind of means like you're assuming they're not getting hurt and getting worse, or not learning a new technique and getting better. Under the same conditions, he would complete approximately 65% of his pass attempts. Okay? So there's an example, and you'll certainly have one of those in your homework. So make sure you highlight that or star it so you know where to look back to in your notes. Okay, the last page, we're going to talk about a dot plot, which is a a graph that is used to represent the distribution of a numerical variable. In a dot plot, the dot plot shows the distribution of a numerical variable, and a dot plot typically displays the results of what we call as a simulation. Now, a simulation is what we did on the first day of class with the beads to represent the juniors and the seniors that were selected for the football team. So keep in mind, each dot represents a trial with a specific number of successes. The placement of the dot shows the outcome of the trial. And outcomes are shown along the x-axis and can be a percent or a proportion. The number of dots above each the number of dots above each outcome show how often it occurred. A dot plot of a simulation visually demonstrates the variance of performance due to random chance. So it shows you the variability of outcomes that are likely to occur. So in this example, we're also going to reference what's called a common statistical vocab word, the law of large numbers. It's when an individual's performance, so the law of large numbers states an individual's performance will get closer to their ability as the number of attempts increases. So an individual's performance will get closer to their ability as the number of attempts increases. Okay, so let's take a look at these. Let's compare these dot plots, okay? You have the dot plot right here on the left. They both display the same information. It's the simulate proportion of made shots, okay? However, clearly the dot plots look a little different. It says, which dot plot represents 7 shot attempts and which in each trial, and which dot plot represents 700 shot attempts in each trial. So in one of these, the player took 7 shots in each trial, and then so they take 7 shots and they record the proportion of made shots. In the other one, the player took 700 shots and recorded the proportion of made shots. So if you're looking, this dot plot appears to be much more spread out than this dot plot. Therefore, the dot plot on the left, this one right here, shows the results of 7 shot attempts, because since there's such a few number of attempts, your proportion of made shots is going to be way more spread out compared to 700, which is going to be much closer together. Okay? Because the law of large numbers says that in a small number of attempts, so what do we mean by small number of attempts? So we'll say like less than or equal to 20. An individual's performance may vary far from their ability. What do I mean by that? I mean their data is going to be more spread out. Okay, so law of large numbers, small number of attempts, your data is going to be more spread out. Okay? However, in a large number of attempts, so we'll say greater than 20, an individual's performance will be closer to their ability. So the data is going to be less spread out. So law of large numbers, or I'm sorry, in a large number of attempts, your data is going to be less spread out. Sorry, I forgot the word out. Okay, so using both the dot plots, what estimate would you get of the player's ability and why? Well, both of the dot plots can, even though one's more spread out than the other, you're going to focus, the estimate of their ability is going to be the center of the dot plot. Notice your center, right above right around 0.3 here. And same with this one, right about 0.3. So I would say 0.3 or 30%. And why am I making that estimate? Because it's the center of each dot plot. Okay? So we are going to talk a little bit more about comparing performance and ability tomorrow, and looking and comparing the LeBron James performances in the regular season, the playoffs. So good luck on your worksheet tonight, guys. And if you have any questions, reference back into your notes, or I'll answer them the next day.